In this video, we're going to start discussion of the third topic of chapter 8, types of reactions. This is a large topic, so we're going to break this topic to three videos, and this is going to be the first video of the topic number 3. It's about acid and base reactions. Let's take a look at this slide. Well, acid and base, these are the very common chemicals in our daily life. Okay, on this picture, it shows you some common fruits and the liquids that can be classified as acid, like a citric acid in oranges. Okay, so they are mild, gives you the sour taste. And here you can see the vitamin C is actually one of the weak acids, and you can see the vinegar. Those kind of stuff used in kitchen. And for base, okay, like bleach, okay, the major component of the bleach is this sodium salt, and this is a very strong oxidant, Cl-O minus. If you dissolve that in water, it will give you sodium and Cl-O minus. And this is a very strong oxidant. It will kill the bacteria. Okay, and some other bases in our daily life includes ammonia. NH3, it smells kind of strong, and we use it to clean the toilet, for instance. Okay, so we do need to have a good understanding about their chemical behaviors, so we can understand the properties better. Let's define acid and base. Acid, it's going to be a substance that can produce proton when you dissolve it in water, like a hydrochloric acid. Okay, hydrochloric acid, we know that this is going to be an acid because when you dissolve that in water, it will produce H plus and Cl minus. And this is the definition. If a substance can dissociate or can provide H plus in water, it's going to be acid. Okay. This table shows you some common acids. Okay. Well, those acids highlighted by this red square are required. In other words, if I give you the formula of those acids, I expect you know first they are acid. Second thing is what kind of ions they can produce. For instance, if you are talking about this nitric acid, when you dissolve nitric acid in water, it will give you H plus and nitrate, NO3 minus. And for perchloric acid, I'll write it here, for HClO4, very strong acid, it will produce H plus and perchlorate. Okay, so that's my expectation. And for base, okay, it's going to be a substance that can produce OH minus when you dissolve it in water. Oh, of course, the water formula is not correct here. The 2 should be a subscript. But anyway, let's take a look at some common bases. Well, here you have total 5 of them. Okay, if you take a closer look of this formula, they have OH group in their formula. So, for instance, for potassium hydroxide, if you dissolve it in water, it will produce 8K plus and OH minus. And if you dissolve barium hydroxide, so it will produce barium cation, okay, Ba2 plus, and O2 equivalent of OH minus. This 2 comes from the 2 here. All right. Again, the compounds, the bases that highlighted by this red square, they are required. Okay. If I give you a formula, I expect you know they are gonna be bases, and also I expect you know how to write the dissociation equation of those bases. Okay. All right. So this is the acids and bases. Now let's take a look at what will happen if you let acid and base react together. Well, here this picture shows you the reaction between hydrochloric acid and sodium hydroxide. What happened here is once you dissolve hydrochloric acid in water, it will generate H plus and chloride. And if you take a closer look, well, it shows you the H3O plus. Well, this is another way to write H plus in water. Okay, let me write it here. So HCl. In the previously, we just focused on HCl minus, right? But when you write in this picture, in order to get H3O plus, it will actually consider water. So it will give you, so H plus will bond with water to generate H3O plus and Cl minus in this case. This is called the hydronium, okay, hydronium cation. And this is a very common way to write H plus in water, okay. If you want me to break this equation to two different steps, then that's going to be something like this. HCl first dissociate to give you H plus and Cl minus, and H plus will bind with water to generate H3O plus. Okay, and if you combine those two sub-reaction equations, then you will have this overall equations. Okay, so do not get surprised if you see H3O plus when you consider the dissociation of an acid. All right, now this is hydrochloric acid. Now sodium hydroxide, well, as we mentioned that for a base, when you dissolve that in water, it will give you sodium cation and hydroxide. Okay, so now you have 4 ions in this mixture: hydronium, chloride, sodium hydroxide. So when you have all 4 of them together in one solution, what will happen here is H3O plus will react with OH minus to generate water, and Cl minus and sodium plus, okay, they are gonna form salt, sodium chloride. Okay, so if you want me to write the chemical equation of this reaction between hydrochloric acid, it's going to be one of the product would be water, the other product would be sodium chloride. Okay, so let me write it here, HCl. Okay, you can consider, if you consider the dissociation of the HCl, it's going to be like this. And for sodium hydroxide, it's going to be sodium and OH minus. Okay, so when you have those two reactants in the same system, they are going to exchange the cations and anions. In other words, the H plus and hydroxide will bind together to form water, and sodium and chloride, they are going to bind together to form sodium chloride. Okay, so that's why we said that two products would be water. That's the product from the reaction between H plus and hydroxide. Okay, the second product would be sodium chloride. That is from the reaction of the sodium cation and chloride. So they exchange the cations and anions. All right, now let's take a look at these two examples, hydrochloric acid and potassium hydroxide. Well, again, like we did for this reaction, let's consider the dissociation of each substance first. HCl will dissociate to give you H plus. Of course, if you want to consider the states, then since you are talking about the aqueous solution of those ions, so you have AQ for those ions. Okay. Now for potassium hydroxide, AQ, it will give you potassium AQ plus hydroxide AQ. All right, now let's exchange the cations and anions. Potassium proton will bind with hydrochloric hydroxide. Okay, so that means one of the products, again, it's water, it's pure liquid, so we use L, liquid, okay, for the state of water. Second product would be the combination of potassium and chloride. So it's going to be potassium chloride. Of course, it's the aqueous solution. Okay, so these are the two products. If you wanted me to write this equation here, so that's going to be water, Al, plus potassium chloride, aqueous. This is the first example. Now, second example, this two reactants. Again, let's consider each one of them separately. For sulfuric acid, HSO4, it will AQ, it will dissociate to give you two equivalent of proton and SO4, 2 minus. Here the two, this two comes from here, okay? In each molecule, H2SO4 molecule, it has two protons. So when it dissociates, it will generate two protons, okay? Now for barium hydroxide, it has two OH groups. So dissociate to give you barium 2 plus and 2 hydroxide. Okay, now let's swap the cations and anions. Again, proton hydroxide will bond together to generate water, and please pay attention to the coefficient. One proton, one hydroxide will generate one water. You have two protons and two hydroxide, therefore you are going to have two water as product. The other product would be between the barium and the sulfate. So the other one would be barium SO4. And here it's going to be a solid. If you happen to remember the table we had regarding the solubility of ionic compound, you will see that this barium sulfate is not soluble in water. So if you mix these two together, barium sulfate will actually form a precipitate as a product. Okay, but anyway, so these are the two products in this from this reaction. Now let's make a quick summary. As you notice that all of those reactions involving acid and base, okay, they share something in common. In other words, as you notice, water is always one of the products. Okay, the other products would be the salt between the metal cation and non-metal anion. Okay, so if you want me to write a general equation for a reaction between acid and base, it can be write like this. So acid plus base will generate water, H2O, and salt. Okay, so this is the general equation. Of course, pay attention to the coefficient. This is a general equation, tells you the two products, but pay attention to the coefficients regarding hydroxide and proton. The coefficient of water could be different, okay, for different reactions. All right, this is the reaction between the acid and base. A very common practice in a chemical lab that can take advantage of this neutralization reaction is titration. titration is most likely is between between an acid and a base. Okay, it's a neutralization reaction, and it's low cost, and it's very efficient, and it's accurate enough for some general purposes. Okay, so actually we will do a lab in about titration. What happened here is, well, you have a burette, and in this burette, it's either acid or the base, okay, with a known concentration. And here, this is the receiving flask. In this receiving flask, usually it's the base or acid. Okay, if this is base in burette, then this is going to be acid. If you have acid in burette, then the receiving flask would be base. So you have certain amount of acid and base in the receiving flask, and before you start the titration, you need to add indicator to this solution. Indicator is a compound that can change color when the acid and base react with each other completely. In other words, indicator will give you color change when the reaction is over. Okay, so before you start, you can see it's colorless, and then you just keep adding either acid and the base into this receiving flask with base or acid until you start seeing the color change. Then you slow down a little bit, okay, and swirl the flask. Keep swirling it during this process, and if the color stays for 30 seconds, most likely that's the time that you need to have. If the color stays more than 30 seconds, then that means the reaction is over. You should stop, and then by looking at how much of the acid and base you used in the burette, you can calculate the concentration of this unknown base or acid solution. Okay, so that's the basic mechanism of titration. And by doing labs, you should be able to get a better understanding about what's going on in this type of experiment. Now let's take a look at this example to demonstrate the stoichiometry calculation for acid and base titration. Okay, the titration of a 20 ml of hydrochloric acid of an unknown concentration. In other words, the receiving flask has this hydrochloric solution, and you have sodium hydroxide with this concentration in the burette, and you have to use 15.77 ml of this sodium hydroxide solution, okay, to react with this hydrochloric solution. In other words, you keep adding sodium hydroxide to this hydrochloric solution. When you add 15.77 ml of sodium hydroxide solution, you see the color change. Okay, so our question is asking you what's the concentration of the unknown hydrochloric solution. Again, this chart we saw it when we do the stoichiometry calculation involving solution, and it will help us for this question also. Okay, so how do we start? Well, the first thing that we need to do is to write the balanced chemical equation for this reaction. Okay, first step, between hydrochloric acid, aqueous solution, and the sodium hydroxide. Okay, the two products, one of them is water, we know this already. The other product would be the salt. Okay, and it's going to be sodium chloride. And this reaction, if you double check, it's balanced already. Okay, so it's 1:1 ratio between the acid and the base. All right, now let's do the stoichiometry calculation, step number 2. Before we start, let's take a look at how we use this chart. Okay, well, the volume A, well, we name that as sodium hydroxide. It's known. Okay, and the mole number of sodium hydroxide, we can use molar concentration of sodium hydroxide to do the calculation. Okay. Molar ratio between the sodium hydroxide, I'll write it here, okay, and the hydrochloric acid, we'll use the molar ratio between the two. It's 1:1 ratio, okay. I'll write it here, molar ratio. Okay, 1:1. And then the last step, remember the question is asking you the concentration of hydrochloric acid. Volume of the hydrochloric acid is known. Okay, it's 20 ml. Okay, once you get here, you will know the mole number of hydrochloric acid. You have mole number of hydrochloric acid and volume of hydrochloric acid. It's asking you to calculate the molarity of hydrochloric acid. So you just need to use mole number of HCl divided by the volume of HCl in liter. Then that will give you how much the MHCl is. All right. So the second step is to calculate the mole number of HCl. And here, this is the calculation equation we need. It's going to be 15.77. Of course, convert this to liter. Okay, 1 ml, 10 to the negative 3 liter. Okay, this is going to be sodium hydroxide. Okay, sodium hydroxide. All right, now concentration of sodium hydroxide, 1 liter of sodium hydroxide it's giving right here, okay, 0.1500 mole of sodium hydroxide. Okay, so once you get here, you are right here, mole number of sodium hydroxide. Now the next thing is use the molar ratio between sodium hydroxide and HCl to find out the mole number of HCl. And 1 mole of sodium hydroxide versus 1 mole of HCl. Okay, and if you do the calculation, it will be 0.0023655 mole of HCl. And we are supposed to have 4 significant figures. Okay, so 4 significant figures. Now the last step, step number 3, you have the mole number of HCl already, and the volume of HCl is given 20 ml. So the MHCl that equals to 0.0023655 mole HCl divided by 20 ml. Of course, convert the 20 ml to liter first. Okay, 1 ml equals to 10 to the negative 3 liter. And if you do the calculation, 0.1183 mole per liter. 4 significant figures. All right. This is the acid at base reaction. Let me know if you have any questions.